Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiq Izwan bin Muhammad Rizan. Now I will continue with the buck boost converter diagram. So the first diagram showing a typical buck boost converter which comprise an input voltage source, the VS, connected to a solid state device. A diode serves as the second switch connected in reverse to the power flow, linking to a capacitor and the load in parallel. The control switch is modulated through pulse width modulation (PWM), commonly using time-based modulation for simplicity in DC-DC converters. The circuit design enables efficient voltage regulation, making it a versatile choice for various applications. Next, showing a buck boost converter for mode 1. The switch is on and the diode is off. So we can see here the switch is currently closed. Acts like a short circuit with zero resistance, allowing the current flows through the switch and also inductor, and then return to the DC input source. The inductor stores charge during this on phase. Subsequently, when the switch turns off, the inductor's polarity will be reversed, sustaining the current flow through the load, diode, and back to the inductor. This mode ensures efficient energy transfer and plays a crucial role in the converter's operation. On the other hand, a circuit showing buck boost converter when the switch is off while the diode is on. So here the switch is currently open. So during this phase, the inductor's reverse polarity release stored energy, which is then dissipated in load resistance here. This sustains current flow in the same direction through the load, effectively stepping up the output voltage. In this mode, the inductor acts as a source in conjunction with the input source. However, for analysis purpose, traditional circuit analysis like KVL, Kirchhoff voltage law, are maintained to ensure accurate evaluation of the circuit's behavior. That's all from me.
So, Bismillahirrahmanirrahim. Next, I will try to explain about the graph of the buck-boost converter. So, first of all, as we see in this graph, when the switch is closed or the converter is on state, the current will flow from the input source to the inductor, and this will induce the voltage. And the voltage will be stored during this state, and the voltage across the inductor will be positive. As you can see, the voltage is high. When the switch is open or the converter is off state, the inductor will discharge the energy into the load, and the current will continue to flow and will not immediately go to zero. And as we can see, the voltage across the inductor will be negative. So next, for the comparison of voltage ratio between buck boost and buck converter, first of all, we can see that for the buck boost converter, it can be lower than the input supply and higher than the output supply and higher than the input supply. And if the duty cycle is less than 0.5, meaning to say 0.4 or 0.2, then the output voltage is lower than the input voltage. And if the duty cycle is more than half of the duty ratio, 0.6, 0.8, or 1, so the output voltage will be higher than the input supply. That's all for me.
So I will continue for the formula part. As you can see here, the derivation when the switch is closed is that voltage across the inductor will be equal to the VD, and then we calculate the value of voltage across the inductor using this formula LDI over dt, and then we rearrange it, and then we change di over dt to change of IL over change of T, and then change of T will be equals to dt, and then when we rearrange it so that change of IL at the left hand side we get this equation for the switch open, it's not that much difference. The difference is only that instead of BL equals to BT, it's now BL equals to B. And then when we rearrange it so that change of IL is equal at the left hand side, we get this equation which is change of IL equals to BO 1 minus D T over L. So for the steady state condition, we already have change of IL for closed switch and change of IL for open switch. And then we just insert the formula that we have just now. So now we have the B output equals to negative BD D 1 minus D, D over 1 minus D. So for the average inductor current, average source current is related to the average inductor current. IS will be equal to ILD, and then we use the formula for the power, so that we have this equation, and then we insert B naught into this equation, and for the final formula we have IL is equal to BTD over 1 minus D square R. For the value of inductor, we have the formula IL equals to IL minus change of IL over 2, and IL and change of IL over IL, we already have the equation from the last slide, and change of IL, we already have the equation from the first slide. So we just insert the equation, and we arrive at the final equation, which is L equals to 1 minus D square R over 2L. And the last part is for the value of capacitor. Ripple voltage in output can be calculated by using this equation. R is equals to D over RCF, and critical value of capacitor can be calculated using the formula C equals to D over 2RF.
Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I'm Irfan Zanuddin, unit number 2015231. So I will be explaining on the application of buck boost converter, specifically in solar power technology. So what is solar power technology? Solar power system technology, it captures energy from the sun using photovoltaic cells, typically made of silicon. And then when the sunlight hits these cells, it excites electrons, generating flow of electricity. And then the solar panels are commonly installed on rooftop or in open areas to maximize exposure to sunlight. So this generated electricity can either be used immediately or usually stored in batteries for later use. So this technology provides a sustainable and renewable energy source. So how the common working principle for um, a solar power system. So this is the basic working principle, which the sunlight will be captured by the photovoltaic cells, and then it will excite the energy, and the energy will charge the battery. So there are some problems that occur with the common systems, which is sometimes there is times that the amount of energy that captures by the photovoltaic cells is not enough to charge the battery. So this may happen due to shaded solar panels and some unfavorable incident angles that happen during that particular times. So this low energy will not be used to charge the battery, therefore it will be wasted. So this is not as efficient as it should be. So there comes the buck boost converters inside these systems, which it help the stepping up or stepping down the input voltage. So if the input voltage is low, the buck boost converter will step up the voltage and make it able to charge the battery. So it will not be wasted. It same goes the other way around. When the input voltage is higher, it will lower the voltage uh, to make the charging process to be good. So this is the example of a synchronized non-inverting buck boost converter in a circuit that is used in the solar power technology. So there are three operations that happen, which is the buck operation, the boost operation, and the buck boost operation. So the buck operation will be activated when the input voltage is higher than desired load voltage. So by controlling Q1 and Q2, it will um, lower the voltage. So in this mode, the energy stored in the inductor is delivered to the capacitor and the load. So for the second operation, the boost operation, this mode will activated when input voltage is less than the desired load voltage. So by controlling Q3 and Q4, this voltage can be increase. So the output voltage can be higher than the input supply voltage. And then the third one, the buck boost operation, it will engage when the supply voltage is close to the desired load voltage by controlling all the switches Q1, Q2, Q3, and Q4 alternatively. So the output voltage can be adjusted to more or less than the supply voltage. So this application of buck boost converter in solar power technology significantly improves system efficiency and the continuous development of this technology align with global goals for a more sustainable future. So that's for me. That is all for me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum. So I will continue to present about the principle of the buck boost converter. So the operation for buck boost converter is based on the principle of the inductor energy storage and switching. The main component of a buck boost converter is have four, which is the first one is inductor, a switch, a diode, and lastly a capacitor. So the basic principle involve the following step, which is the buck mode or step down. The input voltage is applied to the inductor, causing the current can flow through it. And the diode is in the reverse bias during this phase, which is to prevent the current from through it. And next is the cycle of the switching on and off repeat continuously to allow the buck boost converter to handle input voltage both higher and lower from the VO. And lastly, by adjusting the duty cycle of the switch, the VO can be controlled and can be regulated. So next slide is about the advantage of buck boost converter. The main advantage of a buck boost converter is its versatility. It can increase or decrease the voltage as we needed, which is very beneficial in the various application. And moreover, is capable of maintaining a steady output and despite changes in the input voltage, thus providing high efficiency and excellent response to the load changes. And the other advantage is like in the slide, which is affordable and other things. And next slide is about the disadvantage of buck boost converter. So the design and the implementation can be complex, especially for the system requiring high power and high efficiency. Furthermore, they generate VO with reverse polarity, which could be a limitation in the certain application. And the other disadvantages of this converter is the input and charging current is the continuous and no isolation from input and output side. And lastly, the transfer function difficult to be controlled. And for the conclusion, this converter is very good to use as it has high efficiency, versatility, and wide range of application. I think that's all from me. Thank you.